When we see certain things in integrans, we start thinking about something called trigonometric substitution. Here we have the integral of x cubed divided by the square root of x squared plus 4 dx. Before I get into how we're going to do this, let's talk about what we're not looking at. If we had an integral of x cubed divided by the square root of x plus 4 dx, then I would use a substitution, and the process we're about to talk about would not be necessary. Likewise, if we had an integral of x over the square root of x squared plus 4 dx, then I would again use a substitution, and the power rule and everything would be pretty smooth, I think. Here, though, we have the x cubed in the numerator, and it's really the radical that's tipping me off to thinking about trigonometric substitution. It's the square root of x squared plus 4. Now, rather than going from a general to a specific, I'm going to use this specific example to show you how trigonometric substitution works. I'll tell you more about how you would know to do what I'm about to do at another time. But for right now, I'll tell you that since we're looking at a radicand of x squared plus 4, I know we're going to be using the tangent function. I'm going to set up a right triangle. I'll identify one acute angle as theta and then show you that it's a right triangle. And I'm going to identify the vertical side of the right triangle as x, the horizontal side as 2. And what that does is, using the Pythagorean theorem, it gives us a hypotenuse of x squared plus 4. That the hypotenuse is the square root, it's the square root of x squared plus 4. That is the case is not a coincidence in matching the denominator of our integrand. Based on the triangle, we can see that the tangent of theta is equal to x over 2, or that x is equal to 2 times the tangent of theta. That is our actual substitution. X is equal to 2 times the tangent of theta. If that's true, then dx is 2 times the secant squared of theta d theta. That's a result of the substitution x equals 2 times the tangent of theta. This process is a substitution. So I need to be able to substitute x cubed dx and the square root of x squared plus 4. Since x is 2 times the tangent of theta, I know that x cubed is going to be 8 times the tangent cubed of theta. Since dx is equal to 2 times the secant squared of theta d theta, I can include that as a replacement for dx in the integral, 2 times the secant squared of theta d theta. And now what we have left to replace or substitute in our integral is the square root of u squared plus 4. Turning to the triangle, we can see that the secant of theta is equal to the square root of x squared plus 4 over 2, and it follows that the square root of x squared plus 4 is equal to 2 times the secant of theta. Using that, we can replace the square root in the denominator. So at this point, we have the integral of 8 times the tangent cubed of theta divided by 2 times the secant of theta times 2 times the secant squared of theta d theta. So let's pause for a moment and see how we developed this triangle and then how we used it. Again, x squared plus 4 in a square root looks like a hypotenuse of a right triangle. And if that's the case, folks, then the terms inside of the square root, the x squared and the 4, must have been squares of sides of the triangle. And so I had to choose, basically. The vertical side opposite the angle could have either been x or 2, and then the other side would have been 2. I know that I want to use the tangent of theta. Again, I'll elaborate more later. But I wanted to set up the tangent of theta using the x and the 2 in such a way that I did not end up with a variable in the denominator. I'll quickly erase this, but if we had set it up so the tangent of theta ended up being 2 over x, then 2 would equal x times the tangent of theta, and finding a dx would have been tough. We would have to use the product rule, and we've got an x and a theta. It wouldn't have worked out. And so that's one of the reasons I say I want to avoid having a variable in the denominator. When we considered how to substitute the square root of x squared plus 4, it was a similar thing. I wanted to use the angle theta. I needed to use the square root of x squared plus 4, the hypotenuse. I did not want to use the other variable x. And so a trigonometric function related to theta that involved the square root and the 2, we could have either used the cosine or the secant. By using the secant, we avoid a variable in the denominator, and then we have a clean substitution here. Now we can move on with the rest of this exercise. The 2 will divide out, one factor of the secant will divide out, and we end up with 8 times the integral of the tangent cubed of theta times the secant of theta d theta. Notice that we have an odd power for the tangent function. So we break off one factor of the tangent. We're left with the tangent squared of theta times the tangent of theta times the secant of theta d theta. And at this point, we can think of the tangent of theta, secant of theta d theta, as du. And that implies that we want u to be the secant of theta. Converting using a Pythagorean identity, we have the integral of the secant squared of theta minus 1 times the tangent of theta, secant of theta, d theta. Now we essentially have 8 times the integral of u squared minus 1 du. I don't want to do a full u substitution though, because we've already converted from x to theta. So I'd rather just keep everything in terms of theta. Integrating using the power rule, we're going to get 8/3 times the secant cubed of theta minus 1/8 times the secant of theta plus c. Looking back at what we had when we looked at the triangle, we can see that the secant of theta is equal to the square root of x squared plus 4 over 2. So back substituting, we have 8/3 times the square root of x squared plus 4 over 2, the quantity cubed, minus, and you know what, that 1/8 should be 8. It should be 8, minus 8 times the square root of x squared plus 4 over 2 plus c. One final simplifying step will give us an answer of 1/3 times the quantity of x squared plus 4 to the 3/2 power minus 8 times the square root of x squared plus 4 plus c.